The data link layer is the second layer in the OSI, Open Systems Interconnection, model and is responsible for providing reliable data transfer across a physical link between two network nodes. This layer deals with the transmission of data frames between two adjacent network nodes, ensuring that data is transmitted without errors and in the correct sequence. The data link layer performs the following functions. Framing. This layer breaks up the data received from the network layer into frames, adding a header and a trailer to each frame. The header includes information such as the source and destination addresses, while the trailer contains error-checking information such as a checksum. Physical addressing. The data link layer uses physical addressing, such as MAC, Media Access Control, addresses, to identify the source and destination of each frame. Flow control. This layer manages the flow of data between devices to prevent data loss or congestion. It uses techniques such as buffering, windowing, and congestion control to regulate the rate of data transmission. Error detection and correction. The data link layer detects and corrects errors that may occur during data transmission. It uses techniques such as CRC, cyclic redundancy check, to detect errors and retransmission of frames to correct errors. Access control. The data link layer manages the access to the physical medium to prevent collisions between data frames. It uses techniques such as CSMA, CD, carrier sense multiple access with collision detection, for Ethernet networks and token passing for token ring networks. The data link layer is critical for reliable data transfer between network nodes. It provides the necessary error detection and correction mechanisms to ensure that data is transmitted without errors, while also managing access to the physical medium to prevent collisions and ensure efficient data transfer. The network layer is the third layer in the OSI, Open Systems Interconnection, model and is responsible for the routing of data packets between different networks. This layer provides logical addressing and internetworking services, allowing data to be transmitted between networks with different physical characteristics. The network layer performs the following functions. Logical addressing. The network layer assigns a logical address, such as an IP, Internet Protocol, address, to each network node to identify its location on the network. This address is used to route data packets between networks. Routing. The network layer determines the optimal path for data packets to travel between networks. It uses routing protocols, such as OSPF, Open Shortest Path First, or BGP, Border Gateway Protocol, to make routing decisions based on factors such as network topology, traffic load, and network congestion. Fragmentation and reassembly. The network layer can fragment large data packets into smaller packets to be transmitted over networks with smaller maximum transmission units, MTUs. It also reassembles fragmented packets at the receiving end. Quality of service. The network layer can provide quality of service, COS, guarantees for data packets, ensuring that high-priority traffic, such as voice or video, is given priority over lower-priority traffic. Address resolution. The network layer provides address resolution services, such as ARP, Address Resolution Protocol, to resolve logical addresses to physical addresses, such as MAC addresses. The network layer plays a crucial role in the transmission of data between networks. It provides the necessary logical addressing and routing services to ensure that data is transmitted to the correct destination across different networks, regardless of the underlying physical characteristics. It also provides fragmentation and reassembly services, quality of service guarantees, and address resolution services to ensure efficient and reliable data transmission.